Hi everyone, we're here at our fourth and final stop, Buffalo Park. We are just off of North Gemini Drive, and here we are looking at the youngest and most different rock compared to the three other stops that we've made so far. The first three we looked at were sedimentary rocks, and this one is actually an igneous basalt. The basalt here is around 50 million years old and was deposited during the Tertiary period just after the Cretaceous extinction event. The basalt is comprised of about 93% ground mass with olivine, pyroxene, and plagioclase feldspar. The rock is gray in color with a distinct block shape and has oxidation marks along with lichens growing on the blocks. This basalt is porphyritic, which means there is a distinct difference between the size in minerals throughout the rock, and these crystals are euhedral in shape, well sorted, and less than 1 centimeter in size. There's a very common characteristic here within the basalt, which is a 90-degree fracture, possibly due to the freeze and thaw cycles, that form meter-scale blocks that are almost uniform in size, as you can see in the annotated photo provided. One thing to note about the contact between the basalt and the lower-lying Moenkopi that we just saw on our previous stop is that there's an unconformity between these two. This unconformity between the Triassic and Moenkopi formation is about 200 million years of missing time. So what happened during that time? Well, this was technically a period of no deposition where there was a lot of erosion occurring, and it wiped out all evidence of this environment between those two periods. So the basalt flows that we see were deposited on top of that eroded surface, leading to the jump in time that we can see today. So as we went from our third to fourth, we just did about 200 million years of time difference. So yeah, so thank you for enjoying, and this was our final stop.